Welcome back to Math with Miss Murthy's. Today's lesson is lesson 10.6. This is on outliers. 10.6. This is part of our unit on statistics. This is on page 575 of your Reveal Math textbook. As usual, I want you to pause and do the warm-up on your own, and I'll share the solution for you to double check. And also pause and read the standards for mathematical content that we'll be addressing in this lesson, as well as mathematical practices. All right, so today's lesson is to understand outliers and their effect on measures of center for a data set. Right? What does the term outlier mean to you? If you were to split it up into two parts, something that lies outside. Okay, so an outlier is a data value that is very far away from other data values. So it can either be much greater in value or much lesser in value as compared to the other values. So let's consider the data set shown, which ranges from 225 to 780. Now, how do you know if either of these extreme values or any other values for the example is considered an outlier? Okay. So an outlier is defined as a value that lies more than 1.5 times the interquartile range. What does the interquartile range represent? The interquartile range represents the set of data that is the middle 50% of our data, right? So an outlier is a value that is 1.5 times either more than Q3 or less than Q1. So if you look at it, this is my interquartile range. I'm going to be looking for something that is more than 1.5 times my interquartile range in either direction from my Q1 and Q3, from those two quartiles. Okay. So if I look at this data, my interquartile range is 175. So 1.5 times my interquartile range is going to be 1.5 times 175. That would be 262.5. Okay. So I'm going to call these two numbers my upper limit and my lower limit. Okay. So my upper limit is going to be equal to Q3 plus 1.5 times my IQR, and my lower limit is going to be equal to Q1 minus 1.5 times my IQR. Okay, before we move on, I'm just going to copy this data set for future reference. All right, so if I look at this, my IQ upper limit is Q3 plus 1.5 times. That gives me 737.5 as my upper limit. My lower limit is 37.5, right? If I were to paste this here, let's compare our lower limit and our upper limit. My lower limit is 37.5. That is well below the lowest value that I have. Whereas my upper limit is 737.5, which falls over here. Right? So if you look at this, you determine that you have one outlier whose value is 780. Right? Now, we're going to represent the same thing on a box plot. Previously, you saw that you would represent your Q1, Q3, and your median with a box with the 3 dots. And then you would have a whisker starting from the lowest to Q1. And then your next whisker on the other side would be from Q3 to the largest value. Right? But now you see that any outlier is going to be indicated with an asterisk, and you're going to, your box and whisker plot is only going to retain the values that are not outliers. Okay, this is the new box and whisker plot. Now, let's take a moment and think about this. If the outlier is removed from the data set, will our median still be 387.5? Let's consider our data set, right? We saw that the highest value that we have is an outlier. So if I were to remove this, I'm left with 11 data points. what would the median of a data set with 11 data points be? The median is now the value in the middle, which would be my sixth data point, which would be this. Right? Whereas my old median was 387.5. My new median is 387, so it does change. Let's take a look at example 1. This is on page 576 of your textbook. We're looking at ages and years of candidates in an election, and we're going to identify any outliers in our data set. And before we start identifying the outliers, to start identifying the outliers, what is the data that we need from the data set? We need to determine our median. We need to determine our quartiles, Q1 and Q3. And then we need to determine our interquartile range. Right? Now, the first step to determining our median, like we've practiced before, is to arrange the data in order from least to greatest. Okay, that's my data from least to greatest. Again, I'm going to copy it for future reference. And when I look at it, I have 7 pieces of data. So which is going to be my median? My median is the one in the middle. That's going to be 55. Now this time, you'll notice that when we look at Q1, we are looking at the data set that is below my median. So what's the data set that's below? It is not going to include the median itself. So I'm looking at a data set of 3 values. Again, what is the median of a data set of 3 values? It's the value in the middle. So my Q1 is going to be 48. Similarly, my data set for the third quartile is going to be the data set above the median. That's going to be again a set of 3 values, and the value for the median of a set data set of 3 values is the one in the middle. So my Q3 is going to be 63. So my interquartile range is 63 minus 48, which gives me 15. Right? Now, to find out, so I have figured out the median. I figured out the quartiles. I figured out the interquartile range. To find the outlier, I next need to find out 1.5 times the IQR, which is equal to 1.5 times 15, which is 22.5. All right. Now this will give me my lower limit and my upper limit. My upper limit is 63 plus 22.5, so that's 85.5. My lower limit is 48 minus 22.5, which gives me 25.5. Right? Now I'm going to identify my outlier. So let me put my data set back here. So you can see my outlier, my lower limit is 25.5. That's going to lie between these two values. My upper limit is 85.5. That is beyond these two values, beyond the largest value that I have. Okay, so now I can tell from this that my outlier is going to be 23. As you can see, we have the value of 23 as an outlier. Now, what does it mean that 23 is an outlier? When you look at the context, right? When you look at the context, it tells you that the age of the youngest person is an extreme value in the data set, and it is significantly lower than other data values that you have. All right, I want you to pause this right here and do this check problem on your own, and I'll share the solution with you in a moment. All right, there you are. In this data set, there are no outliers. Okay. Now, before we start learning the effects of outliers, the trivia for today: an octopus has 9 brains. It has a central brain and it has a mini brain in each of its 8 arms, which allows them to act independently. All right, let's talk about the effect of outliers, right? Now, the outlier can affect both the mean and the median. But which one do you think is more likely to get affected? I think the mean is more likely to get affected because of the value itself, right? If you have an outlier that is super large, it's going to affect the value of the mean because the mean includes the sum of all values, whereas the median only takes into account the number of values that are there. Okay, so the mean is going to be more affected by an outlier. Now let's take a look at this example on page 577 of your book, right? Suppose you track the daily high temperatures for 1 week and the results are shown in this table, right? Now, suppose the high temperature on Saturday, and before we move on, I'm going to copy this table. Suppose the high temperature on Saturday is 42 degrees Fahrenheit. Now, this temperature is much lower than the other temperatures in the data set. As you can see, they're all like 68 or above 70, right? This data is also an outlier. If you do the calculations, you will determine that this data is an outlier, okay? Just less than the lower limit for outliers. So what we're going to look at is how this outlier affects the measures of center and variation. So to do this, we need to calculate the measures both with and without the outlier, right? Now let's take a look at this. Given the data over here, you can see that the median is 72, quartile 1 is 68, quartile 3 is 74, your interquartile range is 74 minus 68 or 6. So if I were to see, I have 1.5 times my IQR, that's 9. So my upper limit is going to be 74 plus 9, 83. And my lower limit is going to be 68 minus 9, which is 59. Therefore, you can see that 42 is lower than the lower limit and therefore an outlier, right? Now to calculate this, what we are going to do is we have to find out our measures with and without the outlier. So when we do our measures, we figure out that the mean is 67.7. The mean absolute deviation, if you were to draw either your number line or your table and look at the deviations from the mean, you'll determine that the mean absolute deviation is 7.4. The median of this data is 72 and the IQR is 6. Now to determine the effect of the outlier, we also need to see what does the data set look like without the outlier. So without the outlier, I now have 6 values. So my median is going to be the average of the middle two, which in this case, since both of them are 72, my median is still 72. My mean is now 72. My mean absolute deviation is 1.7. And my interquartile range is 74 minus 1, with 71, which is 3. Right. So I'm going to tabulate all of this data over here, right? All these other measures that we have determined for the two. Let's see. This is going to be with outlier and without the outlier. Okay. So I'm going to look at the mean absolute deviation, the median, and the IQR, right? Because the IQR tells me the spread of the middle 50% of data. So if I were to go back, my mean is 67.7. I'm going to show this in 2 different colors, 67.7. The mean absolute deviation is 7.4. My median is 72 and my IQR was 6, right? Now, for the data set without the outlier, you could see my mean was 72. My mean absolute deviation was 1.7. Median was 72 and my IQR is 3. So if you compare these two data sets, what does this tell you? Think for a moment. Analyze this data. Analyze the comparison, right? You can see that the median is the same in both cases, right? So your median in both cases is 72. But look at the mean. The mean is 67.7. When you compare it to your data set, you only have one value below the mean. All your other values are above the mean when you include the outlier, which was 42, right? Whereas without the outlier, your mean seems to be a truer representation of the data set because your values are clustered around that. You have a couple values less than 72, a couple equal to, and a couple higher than 72. Your mean absolute deviation over here, this is 1.7. That tells you that your data is more clustered around the mean. Here, you have a lot more variation in the data just because of the inclusion of 42. And again, your IQR also tells you in this case, your IQR is 3, which means the spread of the middle 50% of values is a lot lower as compared to this case, where your IQR is 6, right? So let's look at what we have here. The median was not affected by the inclusion of the outlier. Without the outlier, the mean increased. With the outlier, the range decreased in value, right? And with the outlier, you can see that the mean is not the best representation of center because most of your values were greater than 67.7. So with the outlier, mean is not the best representation of the center. In that case, the median is the best representation of the center. So when the data does not contain any outliers, you can use either the mean or the median. But when the data contains an outlier, use only the median, okay? While the median might change a little when an outlier is included or removed, it does not change as much as the mean does. Again, so when we look at the spread of the data, if you choose the mean to describe the center, you're going to choose the range to describe the variation. If you choose the median to describe the center, you choose the interquartile range. Okay. All right. Now let's think about this. Suppose Saturday's temperature had been 59 degrees Fahrenheit, which does not qualify as an outlier. If you were to reflect back at this, right? What is my upper limit and my lower limit? My lower limit is 59, right? So it would, with a value of 59, it would not be an outlier. So how does this affect the mean and the median? Think about it for a moment, right? So let's go back to our table. What would happen to our median, right? With our median would stay the same, 72. But our mean in this case will be higher than 67.7. It will be closer to the true mean. All right, let's take a look at this example. Actually, I believe this is the, all right, this is the example on page 579, okay? We're going to calculate the mean and the median with and without the outlier, and then choose the measure that better describes the center, right? So let's copy this table over. All right, now again, will the outlier affect the mean or the median more? Think about it. We'll talk about this in class, okay? Now, again, we're going to calculate the mean and median with the outlier. Just looking at this data, can you see if there is an outlier? To me, it looks like the value of 200 might be an outlier, right? So, let's see. Let's actually do our calculations, right? If we were to organize this data, so I have 20, 30, 30, 35, 50, 70, 200, right? So now my median over here is going to be 35. Q1 is going to be 30. Q3 is going to be 70. So my IQR is going to be 70 minus 30. That equals 40. 1.5 times my IQR is going to be 1.5 times 40. That's equal to 60. So my upper limit is going to be 70 plus 60, which is equal to, and in fact, the way I want you to represent this, again, always write your equations. It is Q3 plus 1.5 IQR, which is equal to 70 plus 60, that is 130. My lower limit is Q1 minus 1.5 times IQR. That's going to be 30 minus 60, that will be minus 30 would be my lower limit. So you can see LL would be minus 30. UL, which is my upper limit, is 130. So my outlier is 200. Okay. Now, let's calculate the mean and median with the outlier. You can see that the mean is 62.1. The median is 35 years. Okay. And we calculate the mean and the median without the outlier. Without the outlier, we have a mean of 39.2 and the median is 32.5, right? Now, let's compare the two. I'm just going to say with and without. And then we have the mean and the median. So with the outlier, the mean is 62. The median is, oops, sorry, wrong spot. The median is 35. Without the outlier, the mean is 39.2 and the median is 32.5. So what does this tell us about our data? Right? Now the mean was a lot more affected by including the outlier, right? It went up from 39.2 to 62. The median is not as affected. The median changed, but it changed very little. So in this case, we're going to say the median best describes the center of our data. Now, why does it make sense that the lifespan of the animals listed in the table is around 32.5 or 35 years rather than 39 or 62 years? Think about it. In fact, let me paste that table over here, right? Let's make it smaller. Let's take a look at this table. Why does it make sense that the lifespan of the animals listed is centered around 32.5 or 35 years rather than 39 or 62 years? Well, if you see, most of our data is clustered around 35, right? We have 35, 30, 30, 20, 50, whereas we only have two values that are much bigger than that. So, therefore, 62 years does not seem to be like a true representative of their average lifespan. All right, I want you to pause this video right here and do this check problem on your own, and we'll come back to the solution in a moment. There you go, the mean with the outlier, median with the outlier, mean and median without outlier. And in this case, you can see that the mean was more affected by the outlier, right? And the median did not change when the outlier was removed. So that would be a better measure of the center to represent our data set. All right, guys, that's about it. So I want you to create a graphic organizer that'll help you study the concepts we learned today, and we'll also reflect on this in class together, okay? That would be your exit ticket. I'll show you the same on the Google form, and that's it for today. Ciao.